think we're started and recorded. Yes. That was the easiest job you'll ever get right there. You're done. All right. Good morning. Thanks to all of you who have braved 8 o'clock to come here. You're pretty hardcore. Now, this is just like church. You don't have to move up, but if you cannot read the lowest row in this slide, you are probably too far away. So you might want to think about that. The good news is that I will release you by 10 o'clock because I have a call I need to make. And so you'll be free to go on to your next destination. Now, if you want to receive the materials you're going to see today in electronic form, the ticket for that is a business card. If you do not have one, you can repurpose one of mine in order to get what you're going to see. The slide deck I gave to 4C was done a week ago when they asked for it. But as you know, consultants are just in time supply. So the real one, the one you're going to see, you can get only by email. So please provide your card. You'll also get an Excel toolbox and some other cool stuff as well. So please provide your business card so that I can match you up. Now 4C wants you on the attendance roster. So if you're not already on either that sheet or this sheet, please do so before you leave so they'll know who actually attended what. Also, this presentation is being recorded. I'm going to move around perhaps a little bit because it's boring for me to stand here. So I'm not sure how well that recording is going to work when I move away from the microphone, but we'll see how that goes. And it's just being recorded as a microphone. It's not being recorded visually. There's no camera on. So just so you know what the rules of the game are here. We'll try to make this as interactive as we can. However, I do have a lot of material to cover. So I want to make sure you get the most benefit you can. And a lot of this stuff, you'll look at the slide and you'll say, yeah, I get it. In some cases, you may require a voiceover to really get the content in your brain. So please pay attention, but don't try to capture everything that's on the slides because you will get the slides, okay? All right, I want to get a little bit of a smattering of what the audience is here. So if you are working in an industry position, please raise your hand. Almost everyone. And if you are a consultant, please raise your hand. Okay, you have to leave the room. No, I'm kidding. We actually train other consultants as part of what we do, and so we're really happy to have you as part of our crowd. And the reason for that is because oftentimes we go to a client site and another consultant has been there, and we want their work to be really good, so our job is easier. So you're actually making it better for us. For those of you who just came in, if you want the content from this class, please leave your business card here. Also, please make sure you sign one or the other of these two registers. You can do that at the end, but please don't forget or you won't have an access to the slide material. If you forget all of that and you come back later, our website is beath.us. It's not hard to figure out. You can go on there, fill out a form, or you'll find contact information there. You can get to me that way. All right, let's get started. Not going to spend a lot of time on me. For those of you that aren't familiar with me, this is the either third or fourth time this class has been taught here at the 4C. We do some client presentations as well. We've been working on Excel skills for a long time. I probably worked on the first VisiCalc spreadsheet that came out the year VisiCalc was launched, which I believe was about 1983 or so. So I've been working in spreadsheets quite a while. I started off in industry. I'm a recovering process engineer, actually. I'm now an environmental person. When I went to school, there was no environmental. In fact, it was kind of a joke, but it's changed a little. Our company now is half sustainability and half environmental compliance. And when I say half sustainability, I really mean it. We are life cycle assessment professionals and also carbon footprint experts. And there's a lot of people in this building that think they are, but I've been in it for 15 years and maybe they aren't quite so much. But anyway, we've learned a lot from our project work, and I'm now at a place in my career when I really want to start giving back and sharing some of the things that we've learned, not only what to do, but also what not to do that can make your life a little bit easier. And so you're going to see some techniques and some tactics that are about formulas and things in here. Excuse me. But an awful lot of it is going to be about design and layout and why you do what you do. Those things are really important, and they're going to make a difference in what you do. So I'm not going to go through the agenda because I kind of broke it a little bit when I put together the slides. When you are putting together an Excel spreadsheet, your spreadsheet and the way it looks, I would like for you to view it this way. This is your resume. This is who you are and how you work to the people that will review your spreadsheet. And probably no one in this room has really thought about it in that way before, but I guarantee you, your coworkers, your clients, your boss, and the people you work with absolutely make that judgment. And they make it within about 5 seconds of the time they open your spreadsheet. So I ask you in this class to start on a project with a little bit of time to organize yourself. I know you're in a hurry to get the answer. It's A times B equals C. What's C? Oh, my boss is waiting. No, take a few minutes to organize what you're going to do. If you will do that, you may find that your overall time to do the task may be a little bit faster. And hopefully you'll benefit from some of the tactics that we're about to share here about how to go about that. And now we have a couple people in our company who mostly build Excel tools right now. And so they have been asked to give some perspective, and some of that is in the slides that you'll see here. Some of it's my perspective, some of it's the people that we have. We have some just amazing people right now. We just hired a guy who's an engineer, and he's also a coder. So we're going to be voyaging more into the VBA world, although we haven't gone there so far because our clients hate it. And personally, I hate it because VBA is hard to read. And so we do our best to do our work outside of that and try to deliver the functionality our clients want without going to that step. So the only reason we would go to VBA is if we really have no choice. All right, so here you are. You are staring at a blank Excel spreadsheet, just like a blank sheet of paper. How do you start? What do you think about? What should be in your mind at that point? That's the question for the day. So we asked one of our lead designers what she does when she sets up a workbook. And so she is thinking about the workflow that's going to happen with the data that you're going to put together. She is thinking about the inputs. How are these organized? And this is a really important fundamental part of the worksheet or workbook you're going to create. Do you want all that input data to live in one place? Do you want it to be spread out in several strategic places for a reason, depending on the users you're going to have and what they're going to do? There is a school of thought that says it would be nice to organize the key inputs and the key outputs all in the same place so that you can kind of see what's happening and you can actually change an input and see how the results change. If you have a lot of input, it may not all fit on the screen. So part of this is actually about screen design as well, laying out what will fit. And think about some of your users have these little small laptops, and so a little bit less is going to go on their screen. So you really have to think about screen real estate and use it, spend it carefully. It is your vital resource. Okay, so you're thinking about where do the inputs live, where do the outputs live? That's a key strategy decision. You're also thinking about how the calculations are going to be done, how you preserve the raw data, and just what's the workflow going to be like for this workbook. Now, a lot of people work with raw data that for a lot of reasons you want to preserve. So just as a sort of a high level thing, most people will bring in raw data and have a separate tab for it, and they'll do their best not to massage that data, not to put formulas in there, so that when that data changes next year, next month, or whatever, you can just put the new data in there and it's not going to break anything that you've created. And also it's clear what the data was before you started operating on it. And then most importantly, what do your results need to look like? All of us are busy. All of us work with people who don't have a lot of time. They want to get right to the answer. So you think about the way a newspaper is organized. You tell the results and then you start layering in the story. That's what's called reporter style. So does your workbook need to be that way? Do the results need to be organized in that way? Maybe. You need to think about that. If this is something that only you are going to use, then fine. But what if you're going to pass along to other people? What if you're sending it out to half the plant? Where does this sit in terms of how informed is your audience? Because that's another problem. Your boss may be looking for one thing, your coworkers for something else, people in the plant that work in maintenance, something else. Some of those people may have really good Excel skill. Some of them may not even know where the enter button is on their laptop. So how do you reach that audience and organize things for best for all of that target audience? That's a hard job. Okay, so then we asked her to sort of make a step-by-step procedure for how to put things together. And you may not follow this, but this is something you might view as the cafeteria line. As you're starting to think about your workbook, you might grab these things and use them, or you might say, I'm not doing that. So it's just something to think about. I will definitely say to you that not everyone does this for everything that they do, but it's there. Use it or lose it. I'm not going to go through the details. We've got a lot of other stuff to cover. So high level, these are the kind of things that I extracted from that designer, several others we have, and frankly, somewhat from my own personal preferences. The first thing is to make a positive impression by your colors, your fonts, and your arrangement. That initial screen that you get when someone opens your workbook is when they form that 5-second impression of you. That's your resume. How do you want that to look? Most people don't spend a lot of time on that, but they really, really should, because your professional advancement, your next job might be catalyzed by what that looks like. Think about that for a minute, okay? Make your required inputs very clear. This is exceptionally important. When I started working with a client that had an emissions inventory, they had, probably 75 tabs in their workbook, and they had inputs on almost every tab, and they weren't identified as inputs. It was complete chaos. Do not do that to yourself. The very first thing that you want to do when you encounter someone else's workbook, go find the inputs and make them a slightly different color. Please not an obnoxious red, preferably something a little bit more mellow. We prefer something like a yellow or a kind of a softer tone that doesn't like blare in your eyes, but it's clear, it's consistent throughout the whole workbook. That's the first thing I would do is, where's the inputs? Let me mark them so I know what they are, because I want to make sure when I'm using that tool that if I'm changing something, I change all the places where the inputs are required, and I know I'm using the right inputs that I want. Ideally, they're collected in one place. Where I live, that's what I like to do, instead of having them scattered on 75 sheets in the workbook. The number one thing that is the bane of my existence is what's called ghost factors. A7 times 4.9 times 42 times 8.33 times 1/42, whatever. All those things that live in a formula, you may know what they are, but you're going to be in another job in a year, and someone's not going to know where your 42 came from. So you might want to point that out. And you might say, well, everyone knows there's 42 gallons in a barrel. No, actually, they don't. The next person sitting in that chair may be an accounting person who doesn't know that. Who knows? So please, don't use ghost factors. The other thing is to make the workflow in either a horizontal fashion or a vertical fashion. I don't know how many spreadsheets I've seen where there's a clump of calculations over here, and there's some more over here, and there's some more over here, and then there's some more over here, and you don't know what the workflow is. So you don't know which formulas are pointing to what. So you're forced to go click on formulas and try to sort out the order. If you have to do that to discern how your workbook works, you have failed. It needs to have a workflow that's either horizontal or vertical, so it's clear to anyone who picks up your workbook what's going on. Okay, we talked about grouping inputs and outputs together. I'm not going to harp on that again. I also like to take a tabular approach to things that is compact. There are some people that think it's really cool to have these extra space rows in there. They think they set out the data and all that. Do not do that. As you start to do that, you're going to break formulas, you're going to have problems with references, you're going to make 3 times the work for yourself. Please, no blank columns at all, and very judicious in your choice of blank rows. Otherwise, you're going to have issues later on because you don't know how your workbook may morph over time and who may take it on. All right, that's enough about that. So what does favorable impression mean? Well, here's some notes that I thought, and a lot of these came from several of my clients who we actually interviewed them and said, hey, what do you like? And they said, first of all, every sheet should start with a title. What is this sheet? I want to know what it is as soon as I glance. And you might say, well, it's on the tab. How many people don't actually look at the tab? They're flipping around from one sheet to another, and if they look similar, they might do the data input in the wrong place. They might change it in the wrong way. So that title really helps them make sure that they know what that sheet is supposed to do, okay? Specified time period. If you're doing a report every year, I want to know as I'm doing the report for the new year that yes, it's the new year, and I really did change the data that goes with it. Now, there's a lot of kind of work details around that. I'm not going to go to that detail at this point, but dates are really important because people tend to use last year's report or last month's report as a go-by. And so if you don't have a good workflow that makes you confident that you have the right data at the right time, you're going to have a problem. Fonts are really important. They make a great visual impression. You should never mix fonts inside your worksheet, at least, preferably not within your workbook. And what font do you use? The primary two are Arial and Calibri. And the reason I recommend those two is because they scale. As you get on a Teams call with people, they're going to say, oh, make it a little bit bigger or make it a little smaller. And as you zoom in and zoom out, some fonts will literally fall apart at certain magnifications. And that's a Microsoft bug. It happens. So don't do that to yourself. Pick those fonts. And while you're at it, you're also talking about colors. Colors can be easily visually appearing if they come from a palette, and you can change the color palette. I'm not going to go through the details of that, but it's possible to change your Excel color palette. Most companies have a default arrangement that they use. The thing that you really want to think about when you select colors is not just how they appear on the screen, but that your client may be old school and only does his or her work by printing off what you have and then looking at it. If you have not selected your colors carefully, when they do that, it's going to be black and white perhaps, and if it is, some things are going to be unreadable to them. And if you're really, really concerned about that, what I suggest you do when you get your workbook set up, if there are inputs and outputs, go ahead and print a PDF and select or some kind of printer, select black and white. And that way you'll be able to preview and see exactly what your client's going to see or your coworkers are going to see when they print it off. You'd be surprised how many people are closet with respect to this behavior. They're not going to tell you, but they really only do their work with their highlighter and a printed copy of what you have. And if you've selected some really pretty colors, when they go to print it out and they can't read it, you're going to get a phone call. So it's something we don't think about. I'm a sustainability guy. I like to think that everyone's working in their computer only, and I've really struggled to get to that point, but I don't work on paper anymore. It's been a 10-year journey for me to never depend on that. It's really hard, but the key is have 3 or 4 screens, and then you won't have a problem. So by the way, if you're working in Excel and you only have one screen, leave the room now. No, seriously, get more than one screen. You really absolutely positively in Excel, and then use the window function and have different worksheets in your workbook up on the screen at one time so you can see when I change this, here's what's happening over here. It will change your life if you're not doing that. Do not do Excel design work on your laptop with your laptop only. You're going to be at half speed. Please, please, beg your company. If your company won't do it for you, buy your own. You'll just be that much better off. Because some of us work from home. You probably got big old screen at the house. That's when you want to do your design work. Okay. Contrast, I mentioned that. Another workflow thing that I think is really critical is that you always want to specify your units. You see here we have column, and each particular column has units specified. I can't tell you how many times I've opened a client workbook, not been clear on what the this is just a best work practice. And some people will vary them in a very long title. Sometimes in the top, in the middle, and the bottom, you're having a hard time figuring out where's the unit really. So I like a separate row for units that way. I can look all the time and I can say, yep, I know where everything is. So if you don't take any other work practice out of this session, please take that one home, tell your friends, do that. It's going to make everybody's life a whole bunch easier. Okay. The layout is important, the color scheme is important, but those units they're the fundamental part of what we all do. Okay. Oh yeah, one more thing, and this is really important too. How you align your numbers. For some reason, most people think it's really cool to have your numbers in the middle of the cell. Okay. I don't know how that became cool, but personally, I think it's awful. Why is it awful? Because your eye doesn't QA the difference between orders of magnitude. But when you right justify them, as you look down the column, if a number is 1,000 versus 100 or 200, it is going to jump right out at you. That's exactly what you want. You want to know when your data is flawed, when you've gotten an answer that you don't expect. And the best way to do that is to write justify so it's really clear that if you have different inputs, you expect to see different results. If they're widely different, you expect them to be so much that it's an order of magnitude or more longer in the way it displays, and that's going to jump right out at you. Okay, so another best practice right off the bat, write justification for almost everything. And now my pet peeve, scientific notation. Okay. Oh, scientists should always use scientific notation. Sorry, not sorry. That is horrible to QA. Your brain does not think that way. The only time you should use scientific notation is if it's so many darn zeros that it just won't fit in your format, okay? Because it's 0.00007. Okay, fine. Use scientific notation. But even then, I'm tempted to still format it because I want to know orders of magnitudes of things, and this is how your brain works. It works by things being lined up in columns. That's just how we think. Okay? I'm going to pause. I've thrown a few things at you right now, and we've got a lot more to cover here, but are there any quick questions from the audience that or comments you want to make from where we're at right now? Is anyone awake? It's 8 o'clock, just checking. All right, got a couple smiles. Two or three of you are awake anyway, so we'll keep going. All right. Making a favorable impression is also explaining your formulas. Where did I get that from? What is A, B, C, and D in the formula? You see this a lot. If you go through AP 42, you'll see stuff like this in there. This is a really good work practice, and sometimes you can just key it yourself, but a lot of times you can also take a screenshot of what your reference is and just pop it right in there. We use a lot of visuals like that. You'll see some of those in the slides that come here, but it's really important to know what your formulas are, how you used them, and how you're color coding things. Now, I work with, first of all, is anyone in this room a lawyer? Okay, good. I can tell my lawyer jokes now. No, I work with a lot of lawyers in what I do. I've been an expert witness at trial a couple times. I've given a lot of depositions. Lawyers really don't like complicated formulas. They really, to the point of they're almost afraid of them. And this is as a class. Obviously, some lawyers are also engineers, so not everyone, okay? But for lawyers, what I have found has been really effective is if you have a formula like this, you can also take that formula and actually display it right along with your data in the spreadsheet itself. And I'll show you in a little bit how you get to that. But displaying the formula as you're showing how the calculation work goes can actually be a big help. So here it's detached in a different place. But what I'm going to show you is how you might integrate that into your actual workflow, your tabular workflow of the calculation. And maybe even for some non-technical managers or non-technical colleagues or the guy at the loading dock, it might also help to display that formula, not as a formula inside Excel, but something you write out that is tracking along with what the formulas are doing. And I'll show you how that works in a sec. So the other important thing, and if one of my staff members were here, she would say, if you send me a workbook and it doesn't have footnotes, I'm going to immediately send it back without reviewing it. Footnotes for where your data came from and how you did what you did and maybe what assumptions you make, preferably right on the sheet where they apply, is a really important best practice because you're not going to be in that chair forever. If you don't do this and someone else has to pick up your work, they're going to have to trust but verify. When I see a number and it's not data from the plant and it came from somewhere else, I'm not going to move forward until I found out where it is, and then I'll have to make that footnote. So now I've repeated work. So if you want to save the next person from repeating your work, then you need to have footnotes that describe what you have. And if your source changes at some point for some reason, please update the footnotes as you move along. Seems like common sense, but in a hurry, most people will kind of forget that. The next thing, and this is another life lesson here, is to make your inputs very important. And the other thing is people tend to color code a lot of stuff in the workbook. They're showing something to their boss and they say, oh, the answer is 27. And so they color code that in a different way. And he says, well, where's the data that you wrote over? So they color code that, but there's no legend. And so you end up with all these stray marks on your paper, on your digital paper, and we don't know what they mean. So please come up with a scheme. And you can see I have a legend here on this one that says this is what we're going to do, not just for your inputs, but you also might want to show by visually coding them which things are calculations, they're formulas, and you don't want people to write over them versus things that you expect people to write over because that's an input. I don't know how many times I see that confused. Someone has a formula, they say, oh no, that formula's not right in this situation. They put a hard number in there, and then that becomes a template for the next month. And guess what? That number sticks in there. I've seen that happen with some stack data with a client. It was 3 years before we caught the problem that there was a day's worth of data that was hard entered because you got readings every hour. You got 8,000 rows. How are you going to catch that? Well, I got a trick for you for that. That will come later. But if you intend to make a change, you need to highlight that in some way so that it doesn't stick and you don't end up with it next month, next year, whatever. Okay. The other thing, this is probably the worst example, or maybe the best example of a ghost factor. This is a loading calculation, and this is the number that takes the nomogram for petroleum that's in AP42, that graph. It takes that and translates into that whole set of nomograms, translates it into a formula. And they have a formula in AP42 for how to do that. But this is a QA nightmare. And when we've kind of put in place a rule in our company now, and I have some slow adopters, but our rule kind of is, if that formula goes more than one row, you probably have done too much in one cell, and you need to spread that out because it's just that much harder to QA. Now, sometimes with a switch or a complicated logic diagram that forks, you might not be able to do that, but I really like for the work to be progressive and for you not to put all your eggs in the basket like is happening here. So there's that. All right, workflow. This is really important. This is a design aspect that's really, in my mind, it's critical. So in this worksheet, we have the calculation flow vertically. Starts at the top, it works through the formula, it provides all of the inputs, and then it gives the result. Notice in that cell B8, notice that I've actually put the formula and stuck it in there so you can kind of see what's going on. That's kind of a helpful trick. The main thing about this, so you sort of get calculation, right? Kind of knows that. Really want those things to be side by side because you are looking at inputs and outputs in a structured way so that things that should be similar, you can see easily whether they are similar or not. Do the throughputs make sense? Do the outputs make sense? I don't know how many times I have worked particularly with entry-level people who are doing emissions calculations, and they come up with a result for a storage tank, and it is equal to the emissions inventory of the rest of the plant. And that does not bother them at all. Well, that really bothers me. Okay, you can't have one storage tank that's the same as all your flares, all your heaters, everything else in VOC terms. One storage tank cannot do that. If you will just organize your inputs and outputs so that they are side by side, so you can see what they are, these kinds of things when you're QAing, hopefully you're QAing, those will jump right out. Okay, so this is the vertical format. It works sometimes. It depends on what you're trying to do. If your calculations are complicated, this may be a better way to go. But if you have a lot of tanks, you might be contemplating flipping it the other way and making it horizontal instead of vertical. So if you do choose to go that way, then it just scrolls off to the right. Now scrolling, the computer programmers in the world will tell you, don't arrange things, they have to scroll off to the right, but I don't care. To me, I'd rather have the logic of working left to right, and I don't care how far it goes. I can follow that. It's fine with me. We're going to talk about unit conversion in a minute, so I won't cover that aspect of this slide right now. But really want that workflow to be clear so people, as they're traveling from left to right, they understand what unit conversion is happening when emissions factors are coming in, where the raw data is. It should be obvious how that sort of wires together just by the column headings you have, hopefully. And you can put notes in there. Oh, a thing about notes. I don't have anything else in these slides about that. Cell notes. They put the little triangle pieces in there. So people tend to be really chatty with those notes and say, hey, Susie needs to get us this number next week. And guess what? People are going to forget that note is there. It's going to be there for 5 years, and Susie's long gone. And, so I hate cell notes. They have a place here and there, but they tend to get lost and forgotten and not updated. And I get handed a client workbook that's 10 years old, and there's still cell notes in there from people that are long gone about aspects of the workbook that don't even apply anymore. I'd much rather have footnotes that are fully visible at the bottom of the sheet, that just are, if they're in sight, they'll be in mind. If they're out of sight, you'll forget about them. So I would say use cell notes with great caution, and just think about the fact that you may not see them, you may not update them, and other people may not pay attention to them. And also, of course, if you have that boss that prints, he might see the little diagonal triangle there, but he's definitely, or she is definitely not going to see your cell notes. So there's that to think about. All right. So inputs and outputs together for storage tanks, I've mentioned before already that that's pretty helpful. And so this is just a reminder that there's a good way to organize that. One thing that I like to do, when you were in grade school, they taught you if you have a column of numbers, you add them up and you get the answer at the bottom. Okay, that's great. May have worked great in the pencil and paper world, but now we're in an electronic world, we get to choose. So tear that away, get that out of your brain. It's much better to have the sum be at the top of your data. Why? Because I might have 8,000 rows. Do you really want the sum at the bottom of 8,000 rows? That's just shooting yourself in the head, folks. Do it at the front. It really makes a big difference. And here you have the opportunity to see what the inputs and outputs are. So as I change things, I can see how the result changes instead of it being on row 8,750 and I can't get there, right? Easily. Now, yeah, you can hide rows and there are ways to get around this, but this is a best practice. Totals at the top of your data rather than at the bottom. The other advantage is it's not going to move around on you. There's just lots of reasons why it makes a lot of sense. This is my favorite example. This is a real live example of a spreadsheet that an engineering company sent to us on a project. They thought it was really cool to do things in little blocks and have little spaces here and there and repeat these over and over again. And color codes that didn't mean anything. And so the lessons learned from this are separating data by spaces and labels makes leverage of the data by a lookup almost impossible. And this is a little small block of data. And what you don't see here is that there are about 500 pieces of equipment on this same worksheet, organized in this way. And yet I've got to mine this data and put it into a mechanical inventory. It was completely ridiculous. So we basically rebuilt the whole spreadsheet just so we could use it. Color palette not consistent. They had color coding that was in one place and not in another. And repeating the labels horizontally. So if you have, like, this is barrels. I don't need to see barrels 20 times across there. You are ruining your precious screen real estate by doing that sort of thing. Yes, you need to show units, but not in every cell. It's pretty obvious that if you have data in a column or a row, hopefully once you specify the units, it should be the same for everything. So don't put the units in every other. That's just crazy. So anyway, do not do this. Do not be my example 2 years from now if I'm ever back here. I don't know. Do not be my example that I get a hold of that I have to show next time. All right. Here's another great example of inputs and outputs. This is a flow sheet calculator that's doing some yield and volume balances around a refinery process unit. So you see we have the user-defined inputs and the calculated outputs. They're stacked up together. And you can see we ran case studies here. You can kind of see them side by side. So what you start to see with this is why it's important for the data to be arranged in this way. So if you look at the columns that say higher rate and max rate down at the bottom, you will notice that the answers are the same, right? but the input data is not the same. So what does that tell you? It should tell you something are broke. That is not the way it's supposed to work, okay? So trust but verify. The computer is not always smart. It's only as smart as the formulas. And one of the ways that you check it is to if I change something, it should move. This is one of your primary tools for Excel. If you build a model for anything, the first thing you want to test is if I change an input, does the output change? If it does not, you have failed. Okay, that seems simple. Think about the last spreadsheet you built. Did you do that? Did you check that to see if it was working that way? I bet you didn't. Okay, so think about that. If you change something, it should change. If it doesn't, it's broken. Okay. All right. So I have a bunch of guidelines here. I'm not going to step through them all. This is a list we came up with a couple years ago. We've since modified it and made some changes to it. But the point here is if you are in a place to specify for your department or group what you expect, then it's a really good idea. The more you can get things standardized within your work group as far as how you do these kinds of things, the easier it's going to be for your group to work together, the faster you're going to be able to go, and the more professional that you will look to the outside world. Because remember, this resume I talked about is the rest of the refinery, chemical plant, whatever. They are footprinting you in their brain as far as whether they trust you, whether they're going to go along with what you say. And part of that is the visual image that these workbooks create. And the more they look professional, the more you are going to be trusted, the more you're going to get what you want done. I see some heads nodding. They know what I'm talking about here. This really is a surprisingly important factor. Okay. Another thing, I came up in the era where a procedure was a 3-ring binder. It was Word documents, and people printed them off, they put them in a notebook, and they never read them again. Okay? Spreadsheets, however, are complicated. You really need your users to understand what you're doing. If you write a big, long procedure, no one's going to read it. So instead, this is the 2000s, this is the 2022. You got to reform your thinking. Okay? So a procedure in your mind should not be, I ask you to make this leap of faith, should not be step 1, step 2, step 3, 27 pages later. No one's going to read that. Instead, consider a tabular procedure. For a workbook, the most logical organization is every tab is a different space. So think of a row of this as a tab, and then specify things about that tab that you want your user to do, and do that in a table. If you do that, then your user will get to an understanding of what you want very quickly. Now, this is not a cookbook. Sometimes it's just a tour guide. It can be high level. It can be more detailed if you want. Depends on how often is this going to get used? Is someone going to use this every month? Are 20 different people with different skill levels going to do this? Or is it just your coworker who's got a master's in engineering just like you do, and they get it, and they just need to be pointed in the general direction? So consider your audience, don't overwrite. But if you do this in this way, people may actually read it. They may actually have referred to it, and they might even, oh my God, they might actually update it when they change things in your workbook. How annoying is it to get a procedure for a workbook that's 10 years old, but someone's changed the workbook, procedure hasn't changed, and now you don't know, am I really supposed to be doing that stuff? It causes a lot of confusion. So the simpler you make this, the easier the management of change process is for it. Okay? You don't think about management of change inside your workbooks. You think about it with your, construction projects and AFEs and all that sort of stuff. I get that. There's an MOC that goes with your workbook as well. And this is it right here. This is how you manage the guts of that. It can be really, really simple. This can be a 30-minute exercise when you're done creating something, when you're done changing it. Okay? All right. Unit conversion. We have more fights about this than any other thing in our company, I think. And I have 8 PEs and 27 engineers, and we fight about a lot of things. But we really fight about this. One thing we all are agreed on is that we don't want ghost numbers in our formula, right? We want a conversion factor to live somewhere. And we'd like to not key that in a bunch of different times. because we're going to make a mistake. So ideally, your factors all, quote, live in one place. But when I say that, do they really, really, really have to live in one place? Or can there be a hybrid solution? And so this is a hybrid solution that I'm personally a fan of, and my crew is divided. Some of those people want to put all their conversion factors in one table and just point to that tab wherever they use that in the workbook. Nothing wrong with that. But as a QA reviewer, I really have come around to the notion of having those unit conversion factors that relate to my workbook in the same sheet where I'm working. But I don't want to key them there. So what you're going to do is take your database, your table, if you will, of all your conversion factors that live somewhere in the tab to the right. And then for the factors you want here, for this individual worksheet, you either copy paste them or you connect them by formula to what you're using there without actually keying the number. Avoid keying the number, okay? But this way you get the best of both worlds, because as a reviewer, if I want to say, oh, did you really use the right factor or not? When I see this down at the bottom, I can have some assurance that, yeah, maybe you did, without having to go to the table and go look up everything every time as I'm reviewing your work. Now, QA is a spot check process typically. No one does a QA by looking at every single cell, but they want to get the trend of, did the user or did the developer generally get it right, or did they not? And so this will give you a little bit more assurance to that. Now, we've actually created a tool to help you with this, and you would think that unit conversion would be pretty easy. But you know what? Go surf on the web and try to find a really nice list of unit conversion factors. It's surprisingly hard to find a really good list, but there is one. And so here's my first test question for the audience. Where is the best list that I know of, frankly, of unit conversion factors that lives out in general space on the web right now? Anybody know? Blank looks. Where do you go to get your conversion factors? Well, you surf how many gallons per barrel and something comes back in Wikipedia or whatever. You might do that. Turns out there's a source, and it's delivered to you free, and it's from EPA. Even though EPA, you might not think of them as process engineers, they have some. You might not think of them as a great place to go get conversion factors, but it turns out Appendix A to AP 42 has a table. Now, you don't need to go scurrying for this, because if I have your business card, you will get our version of the table. Because when you go there, those conversion factors are in an image, they're not in Excel format. Doesn't make them all that helpful, but guess what? We solved that problem. We have an Excel document. You will get it from this workshop and from nowhere else. Order by midnight tonight, you'll get your special TV bonus. Just kidding. Anyway, we'll provide that for you. We've also taken it one step forward, because what they do is they have a factor to go from gallons to barrels, and they might have a factor that goes from barrels to gallons, but they might not. Now, why am I concerned about this? Well, in general, what you want to do with conversion factors, to the extent that you can, is always multiply. And now, if you have a complicated expression that has numerator and denominator, that gets a little tricky. I'm going to cover that in a minute. But for the moment, if it's just A times B equals C, I want to try to multiply if I can. So therefore, I want to use the right factor to do that. And the unit conversion, one thing I really like about doing this, hard to far away, but what the slide says is that unit conversion mass, and it says convert from pounds to tons multiplied by a number. Okay? So if you state your conversion factor in that way, then people won't get it flipped, because that's one of the biggest problems I see in unit conversion, is people getting it flipped. As a QA reviewer, that's the first thing I target when I get a workbook, is I'm going to, get out a sheet of paper, and I'm going to cancel units, and I'm going to make sure that the unit conversion all got worked right. For just one example, I'm not doing this for the whole workbook. I'm going down one row or one column where someone is that works for me. They're going to do that as part of our QA process. That's just something we do. But that mindset of to get from X to Y multiplied by Z, that's a really clear way to state these formulas. And the reason that I bring that up is I didn't make that up. That's what AP 42 Appendix A has. So that's how EPA kind of thinks it should be done. Okay, so I'll show you. This is what that table looks like. Now, one thing I've done, because we made it electronic, is that we've also done it in such a way that you can auto filter for it. So if you want to see all the factors for gallons, all the factors for whatever, then you can filter for it. And in fact, here, I have filtered for, I've selected barrels, gallons, and liters, and you can see these are all the factors in there. And the ones that are yellow are the ones that we added that are some flips, because we did sort of a really clever formula thing to see which ones were inversed and which ones weren't. And it turns out EPA, I guess they ran out of gas before they got them all figured out. So they're not all there. So we added some more. And frankly, there's still some more we don't have. But one of the things that's really nice about this is it kind of standardizes the actual number you use and the degree of accuracy it has. So we used the exact number that EPA had. And for different sources, you can find different versions of these with different significant figures. So you won't get exactly the same answer. So if you want to take out one variable in all the things that you do, use this data, and everyone's using the same conversion factor table, and you'll have the same level of accuracy, at least in your conversion factor. Now, your data may still be all over the map, but at least your conversion factors will be more or less standardized amongst your group. You'll take out that variable as you're trying to calculate things. And who knows, you're right close to a permit limit. This might matter a little tiny bit if you're right at that edge. So just think about that, okay? All right. So this is unit conversion taken to the planet Mars, okay? It is probably over and above what you might ever do, but imagine, back to my example, that you're working with lawyers and they don't really understand unit conversion, but for some reason it's really important because maybe it results in a permit limit exceedance. And now, you know, you're in a hearing or whatever, and you're trying to explain this. So what have I done? What I have done is done unit canceling in electronic form. So if you go down through the rows that have the line, see the slightly blacker line there? We have kilocalories per hour, and what I'm doing is I'm doing the multiplication in those two rows as you would to get to your answer. So I'm moving all the way over to the right side, where if I've done everything right, I'm ending up with metric tons of CO2 per year. Sorry, my screen's really small here. So I'm showing which things are time conversions, which things are energy conversions, which things are conversion factors. And you'll notice that row right below the title where I've given everything a variable number and I've shown the equation as I go through it. Lawyers actually came up with this in a Superfund trial I was in, and they said, this is what makes it clear to us. So this is lawyer speak. So if you ever have to deal with people that are a little bit spreadsheet averse, then showing the formula as you go along like that, so it prints, is actually really helpful. And I found in more and more cases, particularly when I'm dealing with plant people who really aren't savvy with formulas and what they're doing, this actually can help quite a lot. Okay, so it is to the ocean floor. I'm not suggesting that you do this with every one of your calculations, but if you're in a contentious environment, or if you have a calculation that's particularly sensitive, and maybe your boss is a art major who may not be spreadsheet great, then maybe this is a way to go in some circumstances. So it's a tool. If you really have to go to the ocean floor, it's there. If you don't need to use it, fine. Now, at the very bottom here, if you want another great place to go for unit conversion factors, this is a tool. It's a pop-up, and it's called Josh Madison is the name of the guy who put this together. It's called convert.exe. It's a little executable that lives on your computer. It just pops up, but it allows you to see the input and output, and you can select from a whole series of tabs, you know, which thing you want. I use this all the time. I've been using it for like 10 years. I love this thing. It's free. Just go to that website. You can download it if your IT people will let you. Otherwise, put it in your home computer. Maybe someday there'll be an app for it, and maybe there is. I haven't been to the website in a while, There might be an app that you could run. And that would be cool if you had it on your phone instead. But this is really a cool little tool. Now, it's not the same factors that are in AP42, so you might want to use those as a preference, but I will admit that I do use this a lot, particularly when I get confused. You know, you're trying to figure out the conversion factor and you just want some confidence that you picked it the right way. This tool will help you to make sure that you have flipped it the right way, because you put in a number and it shows you the output number right in the tool, so you know which way it flips. So if it's 3 in the morning and you're tired and you're not sure if you got it right, this tool will hold your hand. Okay, so it's a nice little crutch. I like it. All right. We had a client who had 50 process heaters and thought it'd be a really good idea to have a tab in their workbook for the emissions calcs for every process heater. Guess what? We discovered a problem with a couple of the formulas that were used to build that. So we now had 50 pages that we needed to change. Do not do this to yourself. If you have multiple pieces of process equipment, one tab for each piece of equipment is the worst idea I've ever heard of in my life. Do not do that. It seems logical, but you are shooting yourself not only in one foot, but in both feet, and both hands. Do not do that. Instead of doing that, where everything is on one sheet and it's grouped in nice little columns or whatever, or it's not. And by the way, this had a lot of space in it, so it made it very difficult for us to mine it. Originally, we built a mining tool that would capitalize on the format of all these. But guess what the client did then? They also went in and inserted some extra comments in some of the sheets because not all the heaters were the same. And so guess what? They didn't have exactly the same table structure. So now we have a mess. And you can't use a lookup because they put their comments in the middle of some of the data. And so it was just a heart attack. So do not do that to yourself. Think about how your data is going to be organized, and instead create a table. You know, the computer programmers aren't all dumb. You know, they like to put things in tables, and this is a great example of what you want to do. It's just a consolidated approach, more of a database style to it. And when you do that, you're going to be able to spot things side by side. So you're going to be able to find those outliers when you have those numbers nicely, right, justified, and all your calculations can just be pulled across. So if I find an error in a calculation, or God forbid, EPA changes a factor, or you get a new permit, or whatever the reason might be, I can drag the number across all my pieces of equipment. You absolutely want to be able to do that. Please, I promise I'll do this, John, no matter what else. Please do that. Do not make me come behind you and work on what you saw before. Do not do that. I'll be angry. All right. Another thing that people seem to have a lot of trouble with when they're dealing with emissions calcs is source test data. It comes and goes, and sometimes you test some parameters, sometimes you test others, depends on your permit and the regulations and so forth. What I like to do, because I've had so many instances where people have made that kind of a manual process, or someone goes in there and loads the latest data into, you know, one row of the spreadsheet, or in this case, one sheet of the spreadsheet, which I hated. And that data lives in that spreadsheet, and it's kind of hard to compare the test data and kind of make sure it makes sense in a lump. So what I like to see is a tab in the workbook where all of your test data lives. So you can see when the date of which test was, and one row per thing that you tested. Yeah, you may have a performance test, and you may test for 10 different parameters, and there might be 3 runs and all that. At the end of the day, I really want the answers that you're going to use, and I want parametrically, I want NOx on one row and SO2 and CO or whatever. I want those on different rows in this table of data, and then I can write a formula that mines them. So one of the things that I've done here is there's an example formula that shows you how to figure out which of these rows is the most current test data, which is important because you want to make sure that you're using the most current test data. So there's a formula in here that puts a yes in the right-hand column if it is based on all the dates in the table. It is the most recent test data for that parameter, for that piece of equipment. So it just has a little logical if built in around that. So it's there if you want to use that. And then there's a really hairy formula that is used to then put that into the calculation worksheet that actually does the process heaters. But you get the approach here. But if test data is a thing for you, you need to spend a little bit of time on it, because that's the most frequent error I see in people doing combustion calculations is that the test data is not, there's not a management of change process that is effectively getting that test data in the right place at the right time in their emissions calcs. I see that almost all the time. They make it way too manual and people get asleep at the switch. They don't do it. All right. This is another one of my favorite tools, and one of our PhDs came up with this, and I just love this. This is data substitution. Now, the first thing I'll say is, how many of you that work with process data will go get data and will take a monthly average or even a weekly average, whatever, as opposed to looking at the raw data? If you take a monthly average of hourly values and you don't look at them, then you are cruising for a bruising, okay? These monitors, whether it's a flow meter or SIMS or whatever it is, any kind of device that comes in, for whatever reason, you are going to have signal noise, you're going to have mechanical issues. If you don't look in some detailed way at that data, then you're going to be lying. If there's a place, and I remember this, I went to a refinery in the Northwest, and I went in the control room, and they had a limit on one of their process parameters, and it depended on the flow rate of a stream in their CAT unit, and they had a digital readout, and this was flow rate through their CAT, and I looked at the flow meter, and it was negative. And I said, well, does that bother you? Oh, yeah, we've had a work order. I said, well, how long has it been there? Like 2 weeks. And it's showing negative flow on the CAT. So what is that doing? How do you do the calculation? Flow rate times concentration equals emissions, right? So if that number is negative, I am subtracting emissions when in fact I'm having them. This is the craziest thing ever. And if you do that with a monthly or even a daily or certainly, an annual, God forbid, you're going to have that. I guarantee you will have negative numbers in your data. There is no such thing that I know of that is a negative flow, other than if it's a CAT and you're actually having a flow reversal. And if you are, it's time to run really fast because they're about to blow up. Anyway, negative numbers should not happen in flows. There are lots of things that should not happen. So with 87,000 rows, a human is not necessarily going to get that, but there are techniques to basically look for that raw data, substitute and replace them by formulas. I don't know how many of my clients actually try to do that manually. Come on, guys, there are tools. There are ways you can go about that are not all that complicated. They're in Excel. And what you see here on the screen is a scrubbing technique that shows its work. It says, okay, what's wrong? And there are formulas that are detecting what's wrong. And in this case, we actually have conditional formatting that's actually coloring the changed value so you can see why we changed it. So this is showing your work. It's taking the raw data, it's anticipating that I'm going to have problems, and I'm figuring out how I am going to address those problems. Okay? There's lots of different ways to scrub, lots of different reasons why you might want to do that, but this is really, really, really important if you really want to paint an accurate picture of what you're actually doing. Now, there are some programs that require that. For those of you that report under greenhouse gas, you know that you are required to find a place where your data is flagged as invalid, and most of the, like if you have Stack Vision or some of these other systems, they will flag it as invalid. If they do, then you are required to take the last good value and the first good value, average those two, and paint them across the space. And so we have formulas that do that. And now, if you do greenhouse gas reporting, not only do you have to do that, but you also have to tell them how many values you've actually changed in that way. So another great reason to use formulas in a process to be able to do that rather than humans trying to count that up over 8,000 rows times all these different pieces of equipment that you might have that you're reporting for greenhouse gas. And more of that data substitution rule business is going to come. You really should be doing something, whether there is a protocol that tells you how to do this or not, but it's definitely not appropriate to have zero flow or a really small number when in fact you know that's not the flow, okay? You are understating your emissions, and if you are doing that, you are in effect falsifying your report. You are underreporting something. Guess what? If you are the person doing that spreadsheet, I have a whole lecture series about this. You have individual criminal liability for what you just did. Okay? Now, you may say, oh, that's never going to happen. Well, not all of you are as old as I am. I remember very clearly the Huntsman criminal trial, and there were situations as part of that. And by the way, this was where the refinery manager and the plant manager both got convicted and did house arrest for a year or more as a result of what they did. And there were some issues kind of related to this, except they did it on purpose, and they wrote it down, and they found the email. So just like Hillary Clinton, although in this case they found the emails, they found what they read, and it was a problem. So anyway, correct your data. Don't just let it flop around, but first look at your data. Don't just take a monthly average and run with it and go, oh, I'm sure it's fine. It's a computer, it must be right. No, it's not right. Okay? All right. This will change your life. You will not find this anywhere else, I guarantee, because I invented it. Okay. Excel has a very, very unique attribute, which I'm sure no one's told you about. Excel actually stores two values in the cell that you are pointing to. It stores the current value, and also it goes to put the new value in based on any change that's made in the spreadsheet. And before it does that, it asks itself sort of, should I change that or not? Or should I keep the value that I have? Now, this functionality is really hard to address, but it turns out there is a way, and it's to create a circular reference. If you, in your formula, point to the cell itself, you've created a circular reference. And so the way this formula works is basically to say, if value of this cell is set to a certain flag, then change it to something else. Otherwise, if you point to the cell itself as part of that conditional if, don't change it. So what am I doing here? Well, you have a spreadsheet that has a whole bunch of calculations that happen. At the end of this, based on the inputs you have, you can only get one set of answers for that, right? That's the way Excel works. But what if I want to do a case study? I want to put in some different inputs, and I want to see what all my answers are. Well, you could save 3 versions of the spreadsheet and have each one. Sorry, that's caveman. Don't do that. Instead, there's a much better way, and that is to create a case study tool like this that allows you to take, I don't care how complicated the model is, and take your inputs and your outputs and stage them just by using the switch. And so you can see in cell G3, we have the switch. And what we're doing here is we're putting, in this case, a case number, and we're saying that's going to be our test place. Okay, and so you can see the formula. I'm testing to see if G3 is the same as what the column heading is for the column of data I have. And if it is the same, then because the formula is replicated down that column, every place in that column will get changed based on that number. So if I put case 3 and I put some stuff in the input that's in column G, then it's going to write that in my case 3 set. But it's not going to change the other cases because that switch is not set for them. So this is how I can get case study data in. I can basically use column G, and I can put case 1, put whatever numbers I want in there, and then it will save them. Then I change it to case 2, and now it starts writing in the case 2 column for all my data there. And I can change it to case 3 and so forth. So you can have as many cases as you want. You can point to whatever data you want. You can structure this however you want. But the key thing is that circular reference trick where you say, if the switch is set to a certain way, do this. If not, keep the value you have. Okay? Very cool, huh? You'd never in a million years think of that. It was made for a completely different reason, and I saw it on the web somewhere and said, you know what? This would be a great way to do this. So we've been using this for ever since our company was formed. And we do it a lot with pie data. If you have a data historian, imagine that you want to work remotely, okay? And so what you want to do is you want a bunch of tags from process equipment. You want to pull them in from your DCS, but you might be in a hotel working. If you open up your computer and it's got those links, those formulas are looking for a value and they can't see the data historian. Guess what happens? You get pound NAs all over your spreadsheet. It's pulled up. Okay? If you're a consultant, you have this happen to you all the time. So what you do instead is you create a global switch for the whole spreadsheet. And in fact, if I go back here for a second, that Green cell, that's my global switch. On or off. It's off. What that means is I've got that circle of reference in all my formulas that apply, and they're not going to go try to get the data if the switch is on. Switch is on, it says go get the data. So I can control when the spreadsheet goes and gets the data from my DCS or from anywhere else or not, using that same circle of reference trick. And I got to have that with all the formulas. I got to point to that cell and say, hey, look in that cell. If it says on, go get your data. If it says off, sorry, just keep what you have. Okay, so it has a lot of different ways. As a consultant with people that travel around, this changed our life because we work a lot with Pi data. Or there's actually a competitor of Pi, and their workbook tool is called Cake. It's like Pi, only it's Cake. It's really fun. Anyway, for a geek like me, anyway, it's funny. All right, moving on. Turns out that AP42 has something else that you might want. Probably didn't know was there. This is a compilation of physical property data for a whole bunch of individual chemicals. Now, one way to do this is to let's say, for example, I want to do a flash calculation, or I want to do something for storage tanks or whatever, and I need physical property data for a mixture. You can either do that by testing it, but here's one thing that happens with vapor pressure. As you probably know, as vapor pressure gets lower and lower and we get into diesel and some heavier materials, I still need a vapor pressure, but labs really can't measure that. When I get below about a pound of vapor pressure, the results are really unreliable. So that's one of the reasons why you might want this property data. So we built an Antoine coefficient driven flash tool. And so the data for the Antoine coefficients out is in this table 713 of AP42. And again, we made that all electronic for you. It's here and available. We actually added in some gaps they had. And so that's part of the same workbook that has the conversion factors. It also has this stuff in there. So again, some very useful stuff. It also has physical properties in here. So again, these are the sort of EPA approved physical properties. So if you want a vapor pressure, if you have it at one temperature, you want it at another temperature, you can use the flash tool that we created with this data to be able to calculate the vapor pressure for any mixture of any of these materials at any temperature that you might want. So, and it's just for liquids. Gases, that's a whole different discussion we won't have here, but most of us deal a lot in the liquid world, so there's a tool that's available for that. All right, we're going to switch gears now completely and talk about QA. This is a tool. It's not really a tool. It's a so not all of our people think in linear tables, and so one of our really key QA people, this was her visual image that she came up with. This is how her brain works. She's really ADD, and so things are like scraps of paper on the table, and she arranges them. It's kind of fun. But so you have, look at the center of this graphic here. These are the things that she looks at when she QAs a worksheet. And let me tell you, she's going to find every mistake that's there. Amazing. So she looks at the visual imaging, she looks at the workflow, she looks at the math, she notes, and then she has some other stuff. This is a really good little punch list that you can use if you are the person that has to QA, and maybe you have the individual liability for what might be reported, but you didn't make the spreadsheet. You have other people that work with you, and you're responsible for their work. Absolutely need to pay attention to this. You may not care so much about the look and feel, but I guarantee you care about the math. The things that you're looking for are, sorry, question? I heard a voice there. The things you're looking for on math are formula. One of the biggest things that happens, it's rookies mistake 101, formulas that don't go to the whole range. You know, you've got 25 rows, and you look at the formula and it only goes to 20 rows. How many times have you seen that? That's absolutely the first thing you should look for when you get a workbook. People are adding up things in the table range. Did they get the range right? You'll be surprised at how many times they didn't get the range right. Okay. There's another list of things here. I'm not going to go through them. They're loosely defined around what you just saw in the previous table, but this is a good list. This is what Sarah actually uses when she checks workbooks, and she finds everything, and she'll let you know when she doesn't like what you did do, but oh well. This is another really interesting hack. So how many of you have dealt with text issues where your data is supposed to be numbers, but for whatever reason, some numbers end up being saved as text. If they are, what happens is that means they're a zero. They might look really pretty, but Excel thinks they're zero. Can you think how that might be a problem? Well, hell yeah. So how do you find out that that's happening to you? Well, it turns out there is a diagnostic trick, and it's using autofilter. If you filter your column and you see the display on the left, you'll notice the numbers 0.25, 6, 9, 45, they travel in numerical sequence. That tells you that I do not have any text in that column that I think is a number, but it's really not. Okay? Look at the next column. This is a filtration of another column of data. Now you will notice you have to be thinking about it in the right way. 6, 9, 45, 0.125. Wait a minute, 0.125 should be before the 6, right? It's smaller than 6, that's where it should be. Why is it there? It's there because Excel thinks the 0.25 is text. Numbers get preference over text when Excel categorizes them. So the next thing you do, you click on just the 0.25 or all the ones that are that way, and then you get a filtration of just those rows, and you can attack those puppies and make it change. Okay? This is really an important tool. If you suspect that this might be going to you, you really want to go down this pathway. I can tell you that almost every workbook I review, I see this. It's scary. Makes you think about what you didn't know and what you didn't do. Oh, a number that is
always convert my letters to numbers.
Well, frankly, how Excel does things is a little bit of a black box in some ways, and really the only defense you have is things like this, where you're able to see what's playing out. Now, for that, I'm not sure I have a cure for you. I have to think about that a little bit. That's an interesting problem. I think it has a more complicated solution. There probably is a way to attack that, but it might well be sort of formula driven as a way of, you saw how we were scrubbing data, so there might be a formula driven way to create a table that is doing some sort of test that looks for that and gives you a flag in that column, which you can then react to. So this is a static thing here that you have to basically go and do an auto filter in order to look for this in a formula fashion. Probably, I'm not going to say for sure, but probably that's a VBA thing. So we have a kind of a dividing line in our company where we stay away from VBA unless we're desperate, because we have clients that don't allow it. So for that reason, we try to do things with complicated formulas before we go to VBA. So I'm sure there's a formulaic way to do that in VBA. I don't know if there's a formula that can do that in Excel, but I bet, just remember, if you don't take one more thing out of this course, Google is your friend. If you have an issue and you phrase it in the right way, there's a tremendous amount of help out there on the web. And in fact, most of the tricks that you're seeing came from there. Okay? It's all out there if you can just use the right search terms. That's the trick. All right. Now, one of my favorite subjects, lookups. How many of you use VLOOKUPs in your spreadsheet work? Raise your hand. Okay. I want you to think about forgetting that. I want you to think about leaving this room and saying, I will never use VLOOKUP and HLOOKUP again unless I'm desperate. The reason I want you to say that is because these tools, well, they have two flaws. One, they can only look forward in your workbook, across the row or down the column. That can be an issue. But much more importantly, if you insert a column or a row, you can break these things. Okay? And this is an example. I didn't make this up. This came from the web because I wanted to catch it in the action. And so this is somebody who's pointing to this issue. We've seen it a lot. So I now have a ban on VLOOKUPs for new creations inside our company. We do not use it. We're slowly trying to reform those clients that we use in order to move away from this. So your choice is index match and index match match, or a tool which is way better that you may not have heard of. It's called XLOOKUP. And XLOOKUP is like VLOOKUP and HLOOKUP, but it's all one tool, but it can look up either horizontally or vertically, and it doesn't break like this. It's the coolest thing ever. Trust me. Lookup, HLOOKUP, figure it out. Once you get used to how intuitive it is, you will never go back, and you will never have this problem. So, okay, good question. So XLOOKUP was delivered with 2016. However, there is a patch that allows you to go to 2012 or 13, I forget whichever year the one is before that. There is a patch that allows you to go back to that. We have encountered that problem for a client. We built something with some XLOOKUPs in there, and the client said, hey, it blew up. And he actually went and found the patch. So if you have that problem, you can email me and I'll find where he found that patch and I'll send that along to you if that's an issue for you. But I hardly, if you have an older version, you can certainly use index match and index match. Those go way back. So that's not a version issue. Xcopy is a version issue though. All right. There are examples in here on how to use index match and index match. I'm not going to go through those. They're pretty good. They're pretty well explained. But it is, these techniques are a little bit easier to make a mistake with. That's why I like Xcopy. It's much more intuitive. And every time I use index match, I have to go look to an example to make sure I did it the right way. And typically you're testing to see if it does what you want it to do. And so it's just, to me, it's more work to create a new one. There are some tricks, and I wish I had time to go through them, but I probably don't. So this is an example for XLOOKUP and how it works. And again, I'm not going to go through it, but I think it's a lot more intuitive, and you can look at it at your leisure. That's your homework. Go look at that, please. While you're sitting on your plane waiting in the airport, maybe. Range names. How many of you use range names for variables and unit conversion factor? A couple people admit that they do. I thought they were a great thing. Our programmer tried to convince us they were a great thing. Then I ran into this project. One of our consultants, who is no longer with us, decided it was really a good idea to create 250 range names for an emissions inventory we were doing. Then we discovered that there were some naming conventions that need to change. Well, range name table that you're seeing here may look like a spreadsheet, but it's not. It is something that you have to click on one row at a time, enter into another pop-up, and make the changes. So for that reason, I have banned the use of range names in my company. We do not do it unless you want to get fired. Because we had to completely redo this whole thing in order to undo the range names because we had some global changes we needed to make. This is not globally changeable. You have to change it one at a time. That is one of the most compelling reasons not to do this. They're really clever. It sounds like a good idea, but I'd rather just point to the cell, having gone through this experience. Another of my pet peeves, pivot tables. If you're a financial wizard and you're turning out fancy forecasts and what have you, if you go to an Excel training class, they'll be all about pivot tables. How many of you have used them? All right. Pivot tables lie. This is why I don't like them. If your data has changed and you forget to hit the refresh button, your result is wrong. And you can't tell if the refresh button has been hit or not. The only way you will know is to push the button and see if something changes. But the more compelling reason that I hate pivot tables is because they are impossible to QA. The only way you can QA a pivot table is to literally create its alternative in the outside Excel world in order to be able to check it. And when you do that, why the heck did you spend the energy to build the pivot table in the first place? Why would you do that to yourself? Well, I don't give my employees the opportunity to take that stance. I tell them that they're not to do that. And you can do what you want, but I'm just here to tell you, there are examples on the web that you can point to where people will tell you, and this is from an actual website, some of the issues that people have encountered with idiosyncrasies about how pivot tables work. They are not transparent. You cannot see how they're operating. The only way you can check them is to put in an input and see if you get the right output. And the only way you'll know if it's the right output is if you do that calculation independently. Well, you just set up that calculation, so why bother? Use it if you want, but not in my ship. There you go. I had a client say to me, I want to be able to log when something was changed so I know when it was changed. Turns out there's a cool little macro that's out there that you can find that whenever you change the cell, it writes down the time and date. And I think you could probably adapt that code to also include the initials of the person who made the change if you wanted to. This is the kind of thing that if you're in the pharma industry, they have a special overlay for Excel that they're required to do for FDA compliance. Basically, you have to be able to record every change that's made by every person. It's part of their documentation process. I would never have you go do that if you're just working for folks that we all work with. But if you ever need that, here's a nice little cool function for you. I've never used it, but it solved a problem a client had, so I showed it to him. Another piece of data that you'll get electronically, but you can access it right now, is our library of sort of cool stuff that we built. And this is a link to that on our website. You can see it at the right-hand side there, Excel tool development services. There's about 20 different pictures of things that we do. And this is actually documenting the spreadsheet development process. It's kind of a Reader's Digest condensed version of what I covered at the start of this talk. But there's a bunch of other tools that are out there. You can go look at that and you'll see some things. But the Excel workbook you're going to get, the tool workbook, is actually, you know, the real live Excel spreadsheets, whereas up there it's just, you can download the whole thing as a PDF, by the way, and thumb through it at your leisure. So if you're bored at the airport, that's something you can do right now. You don't need to wait for me to send you anything. Okay. And in that photo gallery, this is the chemical mixture flash tool that I mentioned and how it operates, and it works based on that Antoine coefficient data I showed you before. So that's in there. There's also a regulation tool. How many of you work with environmental regulations here in this room? Hopefully a lot of you. Have you noticed that when you are reading through the regulation and you try to download it, and it's a really long one like MAC-CC, for example, it's hard to get exactly what the citation number is, right? You're in A. Well, what part, you know, is it 0.4 or 0.5? You know, am I in 12? Am I in 13? Really hard to figure that out. Well, it turns out there's a way to approach regulations using Excel. Now, you're going to love this or you're going to hate it. And my team is actually split 50-50, but I love it because I want to be able to produce for my clients a table that has the full regulatory citation for every single row in a workbook. So here's A, here's B, here's C, here's D, and we do that actually by formula. We built a tool that we have it going for about 6 states where we have clients right now, but more importantly for the federal. And we also can do permits in this way. And what we basically do, we use a series of formulas which you can't see. You can see there, the left-hand side is kind of a grid. So what it's doing is carefully building the full regulatory citation for each row based on the hierarchy. That's pretty clever how you can do that. So you have a set formula. Go to, let's say you want MAC-CC. You go up there, I say I want 40 CFR, part 63, subpart 60. Go find the red in CFR. Grab the data you want, pop it into this formulas, create these numbers for you. Get then a workbook that you can use that say you want to comment on how you comply with each thing, or you want to create regulatory applicability for something. You can download all those formulas, and then you just make it static. Get rid of all the stuff on the left-hand side, because you only need it initially to create those numbers. That is the full regulatory citation for every row. Once you've created that number, then it's static. You can use that basically. So it's a nice little tool. We've been building that for clients for quite a while, and our people really like it. We're using it right now. We have a client that's used to be a minor source, and they all of a sudden discovered they're a major source, and so they have to create all their regulatory programs. And so we did this for every federal subpart they were under, and they're now going through and developing a compliance plan for every one of those things, and using this kind of approach as a way to go about that. So cool little tool. If for some reason you need to do storage tank calculations, you probably have, if you're a client, you probably have a contractor that's working with you and maybe they have a tool. Turns out we have a tool too, except our tool is a little bit different. We don't charge for it, and you can download it right now. You can go to Argonne Laboratory and go to RPVOC, just search for that, RPVOC, that stands for Refined Products VOC. It is a fully complete, well, semi-complete, AP42 storage tank calculation tool. It also does LDAR. It was built for a very specific purpose, and we took the tank cleaning aspect and we pulled that out because we thought the people that use this tool probably wouldn't have that data. We also made it so you can only do it annually, but it's very easy to conform that into monthly if you have that. And obviously, from when we use it for clients, you know, it does monthly. We have a version of that our clients have. But anyway, it's got all the current version of AP42 calculations in there. And if nothing else, it might be a way that you could benchmark the tool that you're using currently. We benchmarked this against two of the main tools that were out there. Can't remember now. Trinity was one, and I don't remember. Maybe Ramble was the other one that had a tool at the time. And Argonne also did QA on this, so it's available, and we worked with them, and it was used for a very specific purpose, and it feeds some information into the GREET model, which is the fuel transportation greenhouse gas model that DOE uses for a lot of the government planning. We're also a contributor for the GREET model as well, and that's the other whole side of our house that I won't talk about. But anyway, it's a cool tool. We worked on it for a couple of years. We built part of it with client money, and part of it was funded by Argonne, and part of it we contributed on our own, so kind of a joint effort. In the stuff I'm going to send to you, there is something called an Excel toolbox. And this is all the things that you see in this list here. There's an example of each one of those, a working example, and some of them are pretty cool. So I will take a little bit of time and flip through those for you in just a minute. One thing I'll show you in the toolbox is this flow diagram. If you have a workbook that's particularly complicated, it's a really nice thing to put a flow diagram right in the workbook that shows you, hey, how's this thing supposed to work? And it's drawing. This doesn't do anything. It's static, but it really helps your user understand what's going on. And that's a good supplement to the tabular procedure I showed you before. A couple of years ago, we put together this top 10 card of neat little hacks that are interesting formulas. And I won't go through them all, but I will go through the first of them. How many of you have downloaded a PDF and you dropped it in to Excel because you needed it for some reason, and you were annoyed by all the card carriage breaks, and so all the rows are really short because of just how the formatting of that PDF document is, and you said, well, gee, it'd be really neat if I could put those together. Well, turns out there's a formula you can use for that. So you drop your document into Excel, and it comes in with crazy pagination with respect to those spaces. And so in the next column, you just put in this formula and say, okay, take the data that's in my column next to it, and instead apply this to it and make a new calculated result from that. That will get rid of all those extra spaces for you. Pretty cool. How many of you have spent time going through and hitting carriage? I've spent a lot of time doing that. This will free you from that. It's another free little tactic. There's some other tricks. I won't go through them all in here, but they're there. All right, so I'm not going to get to questions just yet because I'm going to go back and try to get, I can do it, make this thing behave. I'm going to try, yeah, here we go. All right, so this workbook, when you come up with it, and the keypad on this laptop is really messed up, so it's not that I don't know what I'm doing. It's you have to really bang it to make it happen. So pardon me if this doesn't work perfectly right. All right, so one of the things that's really important about any workbook that we deliver is a change log. If you make changes, you want to say what you did and when you changed it. That's a really nice thing to have. And if your company is moving towards ISO compliance, it's definitely something you want to get in the habit of doing. So I don't think we need that. Let's see. Say you have a bunch of data, say it's benzene fence line data or whatever, and you want to make a heat map. And unfortunately, this annoying thing is in the way. Let's see if I can make it go away. There we go. So this is a set of calculations, and this is not real data, but it's someone's benzene fence line data in fake. And so you can create a heat map and show what's what. It's kind of a nice little tool if you want to just kind of see where you are. So there's formulas in there for that. This is a conditional format tool that basically you can just set up to highlight when you're over a permit limit or something. This is a really cool tab here. This is called a hard entry detector. And what this does is use a formula that says, I'm looking for a place where the entry in that cell is not driven by a formula, it's actually a hard entered value. And this is a formula to look for a formula, but it's in conditional formatting, okay? But this is really a cool thing, because then when you do this, let's say I have my 8,000 rows of data, I put that in there, and then I auto filter it, and you can auto filter by color. So that I then auto filter for the conditional formatting, and I see my bad data right there. I can see where that person last month changed the number and it's stuck there now because someone took a go by and used that same thing. Or they were asleep talking to somebody on the phone, they hit the key and they put a 0 in a cell where there was some data before. That never happens, right? Oh yeah, it does. So anyway, there's that. I'll skip the VLOOKUP and X. Maybe if you haven't worked with count if and sum if, they're really great tools. There's an example of that here. Here's another little formula hack. This is a formula to look for last good value, and it figures that out. You can use a helper column or not to do it, but it just looks to see if you found a bad data reading or not. So you can look at that. Oh yeah, if you don't know this, there's a way to use the formula text in another column to display the formulas. And so anyway, it's just, let's see if I can show it here. So here we have the cell, and here we have the formula. So if you want to display the formulas just in a column, now you can hit F2, you make the whole spreadsheet go that way. But what if I just want a column where I display the formulas that are getting used? I can just use this formula, equals formula text, and I will get the formula that's being used in wherever I point it to in that cell. So that's a kind of a nice QA trick as well, because so if you do this and you have a place where there's not a formula, it'll show up, you can auto filter on that. So another QA tactic for you. Yeah, that's not too exciting. Let me go past that. This was done a few years ago, so there's some newer stuff that's not in here. Oh, this one I like. Say you are building a task delegation, and you want to create some tasks for people in Excel, and you'd like to have them assigned to different people. So what we have here is a set of formulas that allows you to do this in automated fashion. So look at Jones here. If you notice Jones, he only has one task. But if I go in here, hope this works, and if I put an X in here and I enter it, watch the Jones section. Look at there. He all of a sudden got a new task. So these could be different tabs in the workbook. So I have some consolidated data, and I can, by formulas, split that out and have a display in different tabs. Pretty cool, huh? There's lots of different ways you could use this for different things. One way could be permit conditions that you're trying to assign to different pieces of equipment. Like I want to know all the provisions that apply to a heater. I might be able to do that with this. Lots of different things. Could be your grocery list. I don't know. Lots of different places you might be able to do that. But I think it's really cool how this works. Let's see, what else do I want to show here? Oh, indirect. So imagine you have data and it lives in a number of different tabs, and you want to figure out which data you want to use. Turns out that there is a really clever way to do that. And here's the formula. If you haven't worked with indirect, it's kind of a pain in the rear. But if you can get it to work, it's a good way to be able to select. So here you have some vapor pressure data that you put in the temperature and it gets the results, and it pulls it from different tabs depending on what you put in here. So it's a data-driven reference, if you will. That's how it works. You can see the formula language is a little bit tricky because you have to do some concatenation. If you're not familiar with concatenation, it may throw you for a little bit of a loop, but it's there. You can look at it. Let's see. I think that's the main thing that I want to show you in here. I do want to leave a little bit of time for people to ask questions. So I think I have lost my workbook for one thing. Come on, work. Can't seem to get it back. I can't make this work. There we go, finally. All right. So I think at this point we will go to questions. And we'll say at this point that I'd like to thank you for attending this discussion, and you've been a lovely audience to get here at 8 o'clock. And I'm sure you have a million questions, and I'd be happy to take them up with you individually at some point in the future if you want to reach out to me. But if there's something that's burning in your mind right now, out with it. Yes, sir.